Good afternoon and welcome everyone to the FIS IN 48 Partner Edition. I am Tushar Shetty and I will be the host for the current workshop on cloud native development and test for ZOS on IBM Cloud. The key points for today's workshop will be improve developer productivity resulting in an accelerator release cycle, launch a ZOS virtual server in just minutes, consistent cloud native development, experience with CI/CD pipeline, a secure environment designed for financial service compliance requirement. Today, we have two experts from IBM who will be conducting this workshop. Pradeep Kadiala, he's a senior solution architect at Cloud Financial Service at IBM. And we also have Maha Masri. She's a DevOps for IBM Z Hybrid Cloud Product Management. In this session, our expert will also conduct a demo of an on-demand Z OS system running on a real Z hardware in IBM Cloud, which can help you and your clients increase speed to market and improve software quality. So welcome Pradeep and Maha to this workshop, and over to you.
Thank you. Hello, everyone. My name is Maha Masri, and I am product manager for WASI as a service, one of the main components of what we'll be discussing today. So this is our ZOS Dev and Test virtual environments or infrastructure that can be provisioned on IBM Cloud data centers around the world on IBM Z mainframes. So today we're available in 7 regions around the world: Washington, DC, London, Toronto, Sao Paulo, and Tokyo, and a new data center that just became available in Madrid on September 21st, with others coming soon. We have some very exciting work around automation and setup that is going to be the focus of our workshop today, and that Pradeep will be able to demo.
Thanks, Maha. Hi, I'm Pradeep. I'll be demoing the Z mainframe modernization with DevOps and automation. I'm coming from a financial service cloud, mainly a hybrid cloud environment setup, and also providing solutions on for the industry standards, mainly on security and compliance. You'll be seeing all of this in the demo that talks about and shows some of the key aspects of security and compliance, how secure you can keep your environment, how you can basically do your DevOps pipeline on the secure environment and extend your on-prem onto IBM Cloud with confidence.
So let's look at what we're presenting today. As the product manager for WASI as a service and working with Pradeep Kadiala, our expert solution architect for IBM Cloud Financial Services, we want to show you how WASI as a service can be part of a modern cloud-native development experience for ZOS. Not only will you modernize and accelerate the way you develop, but you will also bring cloud services to your development process so that you can start modernizing your IBM Z applications. I will start with our strategy around hybrid cloud and Z and review some of the services that are designed to help enterprises in the areas of application development and security on IBM Cloud. I will then describe our WASI as a service offering, which is the core part of the DevOps setup that we will be demoing. I will talk about image building and how you can bring your own LPAR images to the cloud for use with WASI as a service instances. We will look at the use cases and impacts. We will then cover several patterns with enterprise reference architectures that have been designed with an automated setup to give customers templates for how to bring their application development to cloud. All of this in a framework that complies with industry regulations and provides security through network isolation. This will be the main focus of what Pradeep will be presenting and demoing.
Here we can see our strategy around IBM Z and IBM Cloud, where you can take advantage of the benefits of both worlds, the agility, AI insights, and speed of cloud, combined with the security, resiliency, and scale of the mainframe. With hybrid cloud, you can optimize for cost and flexibility by expanding access to more technologies. You have choices on what parts can be moved to cloud and what parts can leverage the power of Z to make things better. And the IBM Cloud Catalog offers premium services that are mainframe based as a service that all customers can take advantage of. And these are listed at the bottom here with storage options, ZOS Dev Test or WASI as a service, and Linux One Virtual Server Compute, both of which are available in IBM Cloud Virtual Private Cloud. And all of these services are designed to help enterprises in the areas of application development, securing the compute environment, and providing confidential computing to both data and applications.
Now let's look at some of the offerings in the IBM Cloud for Z portfolio and examples of each of these. These are some of the pieces that you will see as part of the IBM Z reference architectures that we will be discussing and presenting later in this workshop. First is HyperProtect Crypto Services, where you get key storage and key management as a pure SaaS service. This is all hardware-based HSMs based on Z, so we have the only level 4 FIPS protection in the cloud, which essentially means tamper-proof hardware because we are using Z to offer this solution. The middle two are based on our Linux One offerings. On the left hand is the Linux One combined with our HyperProtect crypto services. This is for the workloads that need the absolute most security. So in addition to the HyperProtect crypto services key management, you also have data in memory encrypted for the highest level of protection. The Linux One on-demand virtual servers are also there to give flexibility for the use cases listed here, like backup, disaster recovery, dev test, and hybrid cloud models for getting the best out of those environments. And we have them available in several data centers around the world, so you can have built-in resiliency for your backup strategies and other Linux One use cases. Finally, there is WASI as a service, and this is ZOS in the cloud for dev test, which I will continue to cover in more detail in the next set of charts.
In everything that we described today, you will notice that you will need to have Z expertise and cloud expertise, which may not reside in the same organization within your company, and certainly not with the same people, at least not today. And this is part of what we are working to do from a strategy perspective, is to bring the cloud capabilities to you for ZDev Test, incorporating common tools and processes for your hybrid cloud applications. With WASI as a service, your ZOS system for dev test becomes part of your DevOps setup, and it will be built with security, automation, and continuous compliance. And with this DevOps transformation, customers will benefit by accelerating their speed to market, improve total cost of ownership, improve software quality, and developer productivity. And we will cover the WASI as a service use case a little bit later on, but here you'll see a simple list of what you get with WASI as a service. So first, IBM Cloud data centers are the only cloud with Z hardware available for ZOS dev and test infrastructure. You get on-demand ZOS VSIs, so you pay by the hour only for the system when it's running. You get cloud-native DevOps, if that is what you choose, with continuous delivery for CI/CD and integration with on-prem or cloud-native IDEs. And you can also tie into end-to-end automation, which is a key part of the value of having these instances on cloud. You can automate all sorts of components from your CI/CD, and you can automate bringing up and bringing down the cloud dev test systems so that you can streamline, automate, and improve the cycle time on what you are doing for development and test. And there are a couple of options for your ZOS dev test systems running in the cloud. There is a standard, or otherwise known as a stock image option, which IBM provides for you, or you can create custom images that you build based on your on-prem development system. For the IBM supplied stock image, you get the software stack that is needed to have a ZOS system up and running. Basically, all of the operating system software, some middleware like DB2, IMS, Kix, and all the things you need to have a running system to work with your applications. So we have an image like that available on IBM Cloud. You select it, it takes about 30 seconds to start the instance. 5 minutes later, it IPLs and you have your very own ZOS system. But if you want to base your instance on an existing on-prem LPAR that maybe you use for development today, you could point to that LPAR and use another tool that we have made available called WASI Image Builder to build a custom image based on your on-prem system. The custom image is deployed to cloud storage in two parts, the image and the data volume with your data on it. So that's an option that some customers want because they have either applications already configured or RACF or other configurations for users on that system. And all of that configuration and data will come with the image that they bring forward to the cloud instance. And there are profiles that you can select when you create the instance. And depending on the number of developers that you will have using the system, you can select a smaller or larger profile. Start with the smallest 2 vCPU with 16 gigabytes of memory for about 10 developers and resize anytime if more are needed just by changing to a larger profile for your instance. And these images and data can be configured with key protection or hyperprotect crypto services for added security, which is part of the Virtual Private Cloud VSI creation process. Here we see the part of the development cycle in which these systems are meant to be used. As part of the license agreement, these systems are to be used for early development and test and not for a final production system. For build, unit test, early integration test, and functional test. The same license model is used for ZD&T, one of our other infrastructure offerings that runs on x86. But of course, with ZD&T, it has lower performance compared to WASI as a service because the CPs are not emulated in WASI as a service when running on Z hardware. These systems are not meant to replace your ZOS systems in production. They are meant to make your development and test more agile, more integrated, and easier for adopting new technologies. In terms of adopting these new modernization practices, it provides benefits where IBM Z developers have issues today, like lack of access to systems or the ability to develop their skills with the latest technology, or lack of automation, all inhibiting their development and test productivity. Here we see how the WASI Image Builder tool works to build your custom images. It has a web user interface. You configure it to connect to your on-prem system, and it will then show you a list of volumes that you can select for your image. One nice feature is the volume reduction tool. It allows you to pre-select the minimum set of volumes needed for a system to IPL. You can then test your custom image quickly and later work with your system and application programmers to identify the additional volumes needed to get your application and test data included in the image. The provisioning process can be divided into two parts, image creation and then image deployment to IBM Cloud. For the image creation, you create components to categorize a set of volumes. Instead of creating one giant image, it lets you split them as, for example, a system component that only includes the system volumes, an application component that contains your application datasets, and if your application uses Kix and DB2, then you can create a Kix component that includes your CSD definition, load modules, and source modules. You can create a DB2 component, which includes the table views and data that are needed to run your applications. Once you define your components, you can start the extraction to build your image. And then the final step is to deploy it to IBM Cloud Storage. For the use cases that we see here, early development and unit test is our main one. So setting up these instances for developers as part of a modern DevOps process is one of the things we will focus on here in the demo. For infrastructure testing, like if you want to upgrade a version of Kix or MQ, you can test software updates on a system without having to affect your production environment and see how it works with your applications. The same goes for education. Obviously, you don't want to have someone learning or breaking applications on your production system. It's a great way to provide infrastructure to students in your company to scale as needed for the time that you're running the education. And of course, being able to have that cloud experience is beneficial to the developers, and you can innovate because you have access to your own system to experiment with. Here we see the key value propositions. And we have looked at these already, but the main point here is that it's not about dev and test capacity. This is about application modernization and bringing agility to the development process. You can eliminate wait times related to exclusive access to environments, improve developer productivity and software quality, pay for what you use, so it's an operational expense and not a capital expense. And you can use a custom or stock image and innovate at scale. Here we see some of the main IBM Cloud mainframe modernization patterns. Each of these patterns has an enterprise reference architecture to give customers templates for how they might modernize their applications. So patterns for DevOps, data, APIs, all in a framework that complies with industry regulations and provides security through network isolation. These will be the focus of what Pradeep will be presenting and demoing. He will show you how to design and implement through automation the first three patterns. So with that, I will pass it over to Pradeep to go and show you these demos.
Hello and good evening. I'm Pradeep Kadiala, Senior Solution Architect from IBM Cloud Financial Services. Today I will be talking about solution patterns on Z mainframe modernization in a hybrid cloud environment with industry standards. Before I start, let me introduce myself. I'm leading the effort from IBM Cloud for Financial Services to provide hybrid cloud solutions for Z mainframe modernization. I have 18 years of experience in leading, designing, and implementing solutions for both financial and public industry sectors. Modernizing mainframe application is a daunting task. As much as I leverage the term mainframe modernization, the statement itself is huge. First thing that comes to my mind is, how can I build a secure hybrid cloud environment to modernize using cloud services? Then you would think how easy it is to set up the environment. And then you would think, I'm from financial industry or healthcare. How will this infrastructure comply with my industry standards? What level of security do I have if my data resides on cloud? The demo I am going to show will address these questions. Before I start showing the demo, let's take an overlook. This diagram depicts a secure hybrid cloud environment where system admin can build a custom image and deploy on WASI as a service in IBM Cloud for developers and testers to develop and run unit tests. All this can be performed through secure DevSecOps. First, we deploy IBM Cloud Framework that comply with industry regulations and provide security through network isolation like an air-gapped environment. Next, I will show you how we can build a custom image using WASI Image Builder and deploy onto WASI as a service instance on IBM Cloud. Then we create an optional step wherein the developers can perform development using dev spaces. Finally, we run CI pipeline on mainframe applications to build and deploy on WASI instance for testing. This DevSecOps pattern is designed to build development and test environment at scale with rapid development and improve productivity by accelerating release cycles. In this video, I'll be showing a demo on modernizing the Z mainframe applications using secure DevOps on IBM Cloud environment. I'll be using IBM Cloud services and Z developer tools. First, we will see how Adam, who is a cloud admin, can deploy an isolated secure and compliant environment through automation. Adam opens IBM Cloud Console and selects the toolchain service from navigation menu. Adam will create a new toolchain to deploy infrastructure as code for the IBM Cloud for Financial Services. Adam will then choose the deployment region and already defined resource groups and gives a name to the toolchain. Adam chooses VSI pattern to deploy WASI instance. Adam creates a new repository to maintain the infrastructure as code. Adam generates a new IBM Cloud API key to provision resources. Once all the configurations are entered and submitted by Adam, IBM toolchain delivery pipeline is created. Adam will then go to the code and customizes the resources based on the requirements. Adam will provide resource configurations for key management, resource groups, VPCs, network access controls, subnets, x86 VSIs, and VSIs with WASI custom image. After Adam commits the code, the pipeline gets triggered. A compliance scan is run to validate the infrastructure. All the resources are provisioned on IBM Cloud. Adam checks the WASI VSI instances, VPCs, subnets, network access controls, security groups, and finally, VPN gateway to access the resources securely. In essence, what we just created in the deployment is the infrastructure that looks like this in the diagram. This is a simple deployment with basic components which has isolated network with no access to public internet, just like an air-gapped environment. It has management VPC to manage the workloads that are running in workload VPC. The Bastion host helps to connect to workload VPC using transit gateway. You can connect to the Bastion host using a client-to-site VPN or a direct link, which is not shown here. The workload VPC will have WASI instance. You can connect to WASI instance to your on-prem systems using site-to-site VPN securely, or else you can also connect through direct link based on the bandwidth requirements. VPE gateways will connect the workloads to IBM Cloud services through private endpoints securely. Also at the bottom, you can see the security and compliance that will monitor using the industry compliance controls on the infrastructure. Once we have the cloud environment set up with site-to-site VPN connection to on-prem, data volumes from source Z systems are extracted and deployed in IBM Cloud as block storages, which are then attached to WASI instance. Let's see how to deploy custom image from source Z system to target WASI on IBM Cloud using WASI Image Builder. System admin will log in into WASI Image Builder and will create a source environment to extract the volumes and a target environment to build and deploy the custom image. In source environment, system admin will provide the host name and port and specify the required directory path to extract the volumes. Next, system admin will create the target environment to IBM Cloud using the IBM Cloud API key and providing the target environment resources. System admin will create a custom image by first extracting the data volumes as components from source environment and provides an image name. System admin will then deploy the created custom image into target IBM Cloud environment where the block storage volume snapshots are created. Once the deployment is successful, System admin will create a WASI instance on IBM Cloud Framework for Financial Service using IBM Cloud Console. A WASI instance is created by selecting the IBM Z Linux 1 and custom image we already deployed on cloud. Attach the data volume snapshots that was created during the deployment. Finally, the system admin will successfully create a WASI instance on the workload VPC, which can be used for development and testing. Now we have a development environment created on Financial Service Cloud. Deb, who is a developer, requests Adam to provide a developer environment so that she can perform development and testing using secure DevOps. Adam will provide dev spaces for Deb by creating an OpenShift cluster on the VPC, which was already provisioned in IBM Cloud Framework. Adam opens the OpenShift cluster and installs the WASI dev spaces operator from the Operator Hub catalog. Adam creates a license for the installed operator before use. Adam then creates a G cluster where Deb can use it to create her own dev workspace. Adam updates the configuration with appropriate registry and timeouts to allow time to pull the images from the registry and create the workspace. A WASI devspace URL is generated where Adam can log in and create a devspace for Deb with appropriate IAM access policies. Now Deb with right IAM access policies will log into the dev spaces using URL provided by Adam. Deb will create a new workspace with git URL of an application she is intended to work on. A new workspace is provisioned on dev space cluster where Deb can now use Visual Studio IDE workspace to code and develop COBOL or any other applications. After dev environment gets created, Deb would like to create DevOps on the COBOL application she is working on, so that the commits made in the dev workspaces will trigger the build and deployments onto WASI VSI instance. Deb creates a new toolchain deployment pipeline for her ZOS application using the predefined CI template with secure DevSecOps practices. Deb chooses the deployment region and resource group and gives a name to the toolchain. Deb provides the Git repository details for ZOS application. Deb provides Secrets Manager instance to store the application sensitive data. Deb then provides the details of the WASI VSI instance using a Cloud API key and SSH keys to access the resources securely. Once all the configurations are entered and submitted by Deb, IBM Toolchain deployment pipeline is created. Deb runs the deployment pipeline. The pipeline will run with unit tests, builds the artifacts, and deploys to the WASI dev VSI instance. With this, Deb can now develop code on dev workspaces and deploy the application using secure DevSecOps. Now, let's take a step back and see what are the benefits of having this hybrid cloud environment through DevSecOps to modernize the mainframe applications. The industry compliance needs are addressed with IBM Cloud Framework for Financial Services. You can speed up the innovation by accessing the IBM Cloud services through private endpoints securely. You can safeguard your migrated data with highest level of security using HyperProtect crypto services. Finally, you can operate with agility through automation. Before I dive into application modernization patterns, I would like to emphasize how important it is to first have deployable architecture and DevSecOps pattern to expedite the innovation and transformation of mainframes from a very old COBOL language into a hybrid distributed solutions. Through automation, we had achieved innovation at speed, scaling the environments with rapid development, operational agility, reducing the cost with on-demand environments, and finally, continuous security and compliance. Let's take a break to digest what we have done before I move on to application modernization patterns. In IBM Z mainframe modernization, all existing components of legacy application will reside as foundation in custom image. On top of the foundation image, we can build application-centric patterns, data-centric patterns, and industry-specific solutions. In the interest of time, I'm going to talk about only application-centric pattern, and we will see a demo on how we can extend the mainframe applications to external enterprises and customers using APIs. In application-centric pattern, I'll show you a demo to showcase API development using WASI as a service on IBM Cloud Financial Service environment to expose the mainframe COBOL functions using APIs. We will use ZConnect component, which will allow you to expose the mainframe functions using open APIs.
In this video, we're going to show how new features of the IBM Z and Cloud Modernization Stack can really allow you to increase your digital engagement. We're going to take the example of an environment that already has a chatbot that allows a customer to ask it questions such as, what are my car policy details? The chatbot calls a back-end application and is able to respond with the car policy details. But if the user asks questions such as, what are my account details, or what is my profile, the chatbot does not have access to that information. Therefore, it cannot respond adequately, and instead responds with more details about the car policy. So we want to change that to improve our digital engagement. Our first protocol is with a solution architect, Simon, who's going to use ADDI to get a visual view of the entire application end to end to try and find which application would provide the information for this application. Once Simon is happy that this is correct, he can now create an issue in GitLab or another issue tracking system to provide the developer Deb with the information she needs to create a new API. In this case, Simon has created an issue in GitLab, and he's going to attach the call graph gathered from ADDI to that issue and key information that Deb is going to need to develop the new API for this application. Now the issue is updated, we can move on to Deb to start creating the work that she needs to do to create this new API. Once Deb gets the ticket and she understands what is required of her, the first thing she's going to do is to create a new private development area for her to work on. This will be a copy of the code that she can use, isolated from anyone else. She now has access to code, tools, and the sandbox where she can test her changes in complete isolation from any of the other developers' work. When she's ready to start work, she just logs into her code-ready workspace and begins working. Once the configuration steps to provision her environment are complete, all she has to do is open the environment to begin working. She's now got direct access to the code through a browser-based IDE. If Deb wants to confirm the work that Simon has already done, not only can she look through the code that is available and already been mapped into the IDE, but she can look at the code within IBM WASI Analyze to understand the flow of control between the different programs, the interfaces that they use, and exactly what API or interface she needs to expose. Because a ZOS Connect API designer image was already deployed as part of her project, there's a link available right in the IDE that she can use to go straight to the API developer. The chatbot development team has already provided Deb with the API that she needs to fill in. So the first step is to import that industry standard Open API specification. Once she's done that, the tooling will visually show her the layout of the new API. She can see all of the paths, the components, the schemas, and start to get a feel of the API that she needs to build. This layout and design is very similar with other IBM tooling, such as API Connect. So Deb feels right at home in this interface, and working directly through the browser means she didn't have to configure anything on her local machine in order to get this experience. It's consistent across the organization. When she's ready, Deb can now import the copybook directly into the designer and create a new ZOS asset. In this case, it's going to be a CICS COM area program, but other options are available. She'll enter in the program name, the language of the program, its code page, and also a connection to a CICS system. Notice that many of the fields are already filled in. This is pointing to the CICS region running in the WASI sandbox that she provisioned earlier. This means that when she's ready to test, she'll be able to test it against that deployed and provisioned environment, rather than having to deploy it and configure new connections herself. She's now imported the COM area, or the digital interface, to the program that she needs to export. Deb can quickly check that this is exactly what she was expecting. And when she's ready, she can just replicate that for both the request and the response structure. Now the ZOS Connect designer understands both the API specification that has been provided by the business, as well as the ZOS asset interface that these will need to map to. The final step is to give it a name so she can understand what this ZOS asset does in case it can be reused as part of other APIs. Once the ZOS asset has been created inside the ZOS Connect designer, it's now time to map fields from the Open API specification to the COBOL interface. In most cases, this can be done just by a one-to-one mapping between the field in the COBOL API and a field in the Open API specification. In those cases, things can be easily set just by dragging and dropping from one form to the other. However, if something more complex is necessary, for example, concatenating certain fields together or applying a function over the information provided, that can also be done inside the ZOS Connect design as well. In this case, we need to hard-code a variable into the request structure and also map an input parameter from the URI into the COBOL interface. And when Deb is finished with the API, she'll be able to test it immediately. Because it's all been deployed in the background, there's no need to deploy or move this to ZOS manually. Deb can immediately test the API directly from the IDE just by clicking the Test button. Selecting the Test button opens up a small form-based IDE where Deb will be able to test the API. Here, she's not just testing the API against a stub or a mock, she's testing it against a real version of her CICS application running in the ZOS sandbox that she provisioned earlier. So she's certain that it's going into CICS and into her COBOL application and returning real data. This means that when she's ready, she knows this is the right application and that things have been tested reasonably well. So she's called her API and she can see the customer data that has been returned. Deb's API has now been built successfully and is ready to be distributed to the rest of the organization. While Deb has been building the API, all of the new API projects and all of its assets have automatically been added into her IDE. This means when she's ready, all she needs to do is stage these changes, add a commit message, and then push her changes back to the repository. Now that her changes have been pushed back to the Git repository, it can now be built, tested, and deployed as part of a pipeline. So we can now start to test the entire end-to-end application. Now we'll go back to our chatbot. Now if we ask for account details, we can clearly see that we get the information back about the user's account details. So from end to end, we've shown how the new capabilities within the IBM modernization stack allow us to build new digital engagement into existing applications running on the IBM Z platform.
Application-centric pattern will expose your applications to customers and clients without disrupting the core systems. All of this can be implemented with DevSecOps on secure IBM Cloud framework. Let us take a brief look at how we enhance the core mainframe application by migrating the data using data and AI patterns. Now that we have a robust hybrid cloud platform with APIs, we can enhance the core application with front-facing applications, as well as we can generate reports, analytics, and perform AI through data and AI patterns. In this diagram, you will see the Z tools and IBM Cloud services to perform data migration on batch or real-time data. ZDIH is a digital integration hub tool that will reside on Z systems and will send real-time events to IBM event streams for processing real-time data. Aspera is a high-speed data transfer service using fast, adaptive, secure protocol that transfers large data at lightning speed, reducing any bottlenecks using patented technology. ZConnect, as we have seen, will provide data at request using APIs. All the data that is stored can be used for Watson AI to generate models and integrate back to the front-facing applications using generative AI like watsonx services. Now let's recap what we have done so far. We created IBM Cloud Framework for financial services through automation, which complies with industry standards. We also showcase the importance of DevSecOps with shift-left security using compliance checks and vulnerabilities, and improve the development and test cycles at a very fast pace. Once we have the infrastructure with DevSecOps, we went through modernization of mainframe applications through application, data, and AI-centric patterns. With that, I conclude my presentation. Thank you.
So thank you, Pradeep and Maha. I think it was kind of an amazing session. I hope this session, helps out our startups in terms of their cloud implementation and whatever they're doing in the fintech space. Your profiles and your email and contact details have been already mentioned in the exhibition hall right now, so people can reach out to you directly, and feel free to connect to them or over LinkedIn or any channels that you feel relevant. So again, thank you so much, and we're looking forward to more such engaging sessions with you. Thank you, everyone.
Thank you for
Thank you.
having us.